Hi, this is Mrs. Tellas. We're going to be going over section 3.2, which is determining if a table, an image, or an equation is linear or nonlinear. So you did a little of this in middle school. Hopefully you'll remember some of it. So if you remember, linear means a straight line. I'm going to type that because I can type lots neater than I can write. So it's a straight line. And nonlinear means not a straight line. So anything else, curves, angles, circles, ovals, anything that's not a straight line is nonlinear. So lots of things fit in that nonlinear category. Okay, so if we look at these images, this first one is called a parabola. It is nonlinear because it is not a straight line. The second one is a straight line, so it is linear. Okay, we've got more of these. Okay, why don't you press pause and try the rest of these? I think there's 6 more, and then I'll go and do them as well, and you can check to make sure you're correct. So number 1 is linear, and number 2 is nonlinear. We've got a straight line on number 1, and we've got a curve on number 2. Number 3 is also nonlinear. We've got 2 curves there. Number 3 is nonlinear, 2 curves. 4 is a parabola, so it's nonlinear, and the last one is linear, a straight line. Hey, so I hope you think the images are easy. Okay, the tables. So if we do a table, we look for the slope on the table. So we have to calculate the slope from the table. So we know that the slope in a straight line is calculated by how the y is changing over how the x is changing. And that delta right there, that's a letter, and it means change. Okay, so it's the change in y over the change in x. So if the slope is constant or staying the same, it is linear. And if the slope is varying or changing, it is nonlinear. So if we look at the first table, we can decide linear or nonlinear by how it's changing. Well, since it's y over x, I'm going to start down here. I notice that the number goes from 36 to 30, so the number's going down, so it's minus. So if I take my calculator and do 36 minus 30, that's 6. So it changed by minus 6. So if I look here, if I do 30 minus 24, that is 6 again. So since it's down, it's minus 6. And 24 to 18, 24 minus 18 is 6. And since it went down, it's minus. So the top number in my slope is negative 6. And then I do the same thing on the top. So from 3 to 6, I would have to do 6 minus 3, which is 3, and it went up. 6 is higher than 3, it's plus. Same thing here. 9 minus 6 is 3, and it went up, so it's plus. And same thing here. 12 minus 9 is 3, and the number went up, so it's plus. See how these are all the same? That means it goes in the denominator. This is a linear table. You can tell that because see how these numbers are constant? They went in the numerator. And these numbers are constant. They went in the denominator. So now let's look at the second one. So from here to here, I can take my calculator and do 9 minus 2, and that's 7. And since the number went up, it's positive. So from here to here, I can take my calculator and do 20 minus 9, which is 11. And the number went up, so it's positive. And 20 to 35, I can take my calculator and do 35 minus 20, which is 15. And it went up, so it's positive. So right now I've got 7 over something, 11 over something, and 15 over something. And I don't know what the something is yet, so I have to go up and do the x first. So if I go up here, you can see from 1 to 3, 3 minus 1 is 2, and the number went up. 5 minus 3 is 2, and the number went up. And 7 minus 5 is 2, and the number went up. So my denominators are 2. Well, these are not equal. If you do 7 divided by 2, that's 3.5. If you do 11 divided by 2, that's 5.5. And if you do 15 divided by 2, that's 7.5. These are not equal fractions. This makes a non-linear image if I were to draw it. Okay, and the other thing you could always do if you're not sure is you can graph it. You can always get a piece of graph paper out and graph it and see if it makes a straight line. Okay, so that's the second kind that we're going to do. Now, some of the tables go up and down rather than sideways. Let's do one that goes up and down. We'll do this one. From 0 to 16, the number went up. 16 minus 0 is 16. From 49 to 16, or 16 to 49, the number goes up again, and then I take my calculator and do 49 minus 16. That's 33. See how these are not the same? And 49 to 100 goes up, and 100 minus 49 is 51. See how those are all different? It makes different fractions, but I need to make sure that they're not equivalent somehow. So I go over here. 0 to 4 goes up by 4. 4 to 7 goes up by 3. And 7 to 11 goes up by 3. So 16 divided by 4 is 4. 33 divided by 3 is 11. And 51 divided by 3 is 17. These do not equal each other. This is non-linear. Okay, so it works exactly the same. I put the y's on top in the fraction, and I put the x's on the bottom. And I'm looking to see how the number's changing. All right, last thing is the equations. So what you're looking for when you decide if something is linear in an equation is you look to see if you can write it in y equals mx plus b form, which is slope-intercept form. Okay, so you may have y equals 2x minus 5. See, m and b actually, m stands for the slope and b stands for the y-intercept. That's a different lesson. But those are numbers. The x and the y are usually there. Okay, and then notice a couple things here. The y has an exponent of 1 and the x has an exponent of 1. That's required for it to be linear. If there's a different exponent other than 1, it's nonlinear. Okay, so we could also have y equals 5x plus 10. That would be linear. We could have y equals 3x, because then the plus b would be plus 0. So just y equals 3x would totally work. We could have just an x, like x equals 7. That's linear. Or y equals 3. That's also linear. Okay? Mostly look for your exponents, like this. So see how these all have exponents of 1 because they're not showing? If it's got an x, a y, or just an x or just a y, it's probably linear. Okay, now one thing about the x, it cannot be in the denominator. Okay, it has to be up top in the numerator. All right, so let's go through these together. All right, y equals x plus 9. Well, it's in the right order for y equals mx plus b. M would be 1 and b would be 9. This one's linear. Notice that the exponents here would be 1 on the x and the y. It's linear. Okay, let's look at this one. So y equals 3/5 x. So 3/5 would be my m, and plus 0 would be my b. This is linear. Okay, see how the exponents are 1s? Yeah. All right, let's look at this one. Notice that this one has an exponent of 2. Did you notice that? That one's nonlinear. Okay, same thing for this one. It has an exponent of 2. It's also nonlinear. Okay, let's go over here. Y equals 3.8. That's linear. Okay, it's got a y and it has an exponent of 1. Okay, now we could rewrite this. Y equals 0x plus 3.8. But it's the same thing as this. It's linear. Now this one's got a square root in it. That is nonlinear. Okay, because we don't really know how to graph square roots yet. Okay, this one's got x in the denominator. That one is also nonlinear. Or I'm sorry, x in the exponent. This is nonlinear. And this has got x in the denominator. It is nonlinear as well. Okay, I hope you understand. Okay, so tables, you look for the slope, the change in y over the change in x. If they're all constant, then it's linear. And on these, you're looking for exponents of 1 for both either x or y, or either x has an exponent of 1, y has an exponent of 1. It can't have anything fancy in it, like a square root, or put x in the exponent, or put x in the denominator. The x has to be in the top. Okay? All right, so real quick, let's do this one. A linear function y equals negative 8.5b plus 55 represents the amount in dollars. So this is dollars right here, of money that you have after buying X books. This is supposed to be an X, not a B. We'll change it. Okay, find the domain of the function. Well, this would be from last chapter. So the domain is the X, so it's this one. So if we make a table, and we put this y equals negative 8.5x plus 55 in, we can choose what we want to be the domain. So we could buy 0 books, and if we did that, we would still have $55. If we bought 1 book, let's use our calculator there. Whoops. 55. We'd have $46.50 left. If we bought 2 books, so $55 minus 8.5 times 2, we'd have $38. And we could keep going here until we got to the negatives, because that would mean we ran out of money. So let's try 5, just to see if we can buy 5 books. I'm pretty sure we can buy 3 and 4. Let's try 5. So negative 8.5 times 5 plus 55. I can buy 5 because I'm left with $12.50. So let's try 7, because I think 6 will work too. Let's try 7. Y equals negative 8.5 times 7 plus 55. We're looking for a negative. Once we get to the negatives, there it is. This is a negative 4.5. That means I don't have enough money to buy 7. Okay, so my domain is 0. I could buy no books, and I can buy all the way up to 6 books. So my domain is 0, 1, 2, 3, 4, 5, 6. Once I get to the 7th book, I don't have enough money. So that's as much as I can buy. So that's my domain. Okay, all done. You have a worksheet to do over linear and nonlinear, and you also have a quiz. Now, on this quiz, there's only 2 choices for each, linear or nonlinear. So this is one of the very few quizzes that you can only take one time. So I hope you understand. If you don't, give me an email, please, or I'm on conference from 10:30 to 2:45. You can jump on and ask as many questions as you have. Thanks.